Yeah, I know.
Your defense of we should slow down and work at a normal pace is being tarnished by you saying that you enjoy this class because we learn new.
I mean,
things
but
every
like,
day.
but couldn't we like learn new things each lesson, and then now we're doing 2 lessons?
I don't
So
care that
both
we
of
have
these
to
lessons are about completing the square.
That's fine. Never mind.
We've already talked about it.
I'm fine with the pace we're going.
Y'all, you know what happened during the
You
meeting
did
on
what?
the board, and I looked at it.
I never used that.
I mean, because you probably write it down when it's up here, but if you're
Oh no!
absent,
Why did I fold this?
I don't know. You like holding it?
because you folded under pressure.
No.
Okay. Good. Was that a
No, it was really, really bad.
I always
Oh, I didn't even get it. Okay.
I should have said something like because you were nervous, and then made him ask, "Wait, what?" And I would have said, "Yeah, there was a lot of pressure. You folded it under the pressure." But I missed the opportunity, and I ruined it. I guess I should probably turn off the music. Yeah, now I gotta pause the video.
Oh, he's such a good teacher.
Nah, I don't know about that.
Yeah, I know. That's what they do. Like, oh my god.
Hey, you weren't supposed to agree with me, like being mean to myself. So, yes, we're doing 2 lessons, but only 5 homework problems.
So like one lesson.
Yay.
Yeah, and there's only 1 question from 522.
Amazing.
I like when we do this.
Wait,
You do less homework.
when you look at it,
You
it
could
jumps
have
from
been like,
77 to 89. You're like,
So-
right.
In the grand scheme of things, of life, of whatever, we have content we have to get through, right? We'd rather get through it quickly and then be able to like have fun at the end of the year than moving
Yeah.
slowly and
I'm-
maybe not fully covering something before you guys have to take the test and then doing actual like schoolwork for the
Because if
whole
we
year.
go this quickly, then if I don't get something, I'm gonna have more time.
Absolutely.
Absolutely.
Absolutely. It's like absolutely, but
It's
you
like
know.
when
with
you
a
said
toot.
training the patoot.
Alright, so the idea of completing the square. No one ever told me that all we had to do was complete the square. Because no one ever told me that quadratic expressions represent a realistic thing that's happening.
Oh, right.
So when we think about completing the square, it's a physical process. Like, even though we can do it all algebraic, what we're actually doing is making it a nice model. We're making the dimensions of my object turn into a square. So you do need algebra tiles that I had out for each of you. So pull out an x squared tile and some 1 tiles and some x tiles. Like, we're working with x's today. The blue is the x. Blue is x value. Like light blue.
Wait, wait.
Yeah, the dark blue is a
This one,
single.
right? Okay, sure.
Yeah, dark blue is a single.
These are the
Now, what am I even doing? I know what I'm doing. How do you have so many 1 tiles? Mine don't even.
You can get another bag if you want.
I'll just steal
Some of the bags are missing.
Oh.
You just got them on your table.
I worked to get them out of the bag.
More like you said that for 3 seconds.
I know because I'm
Define your smart.
If we try to model a square that is x plus 2 squared,
Oh my god.
Look.
Okay, so I'm gonna make sure these don't fall everywhere.
x plus 2 squared.
Are we supposed to do that?
Yeah, I'm going to turn on my other screen and be able to show on there. Because x plus 2 squared would actually be, when we do the multiplication, x squared plus 4x plus 4, right, equals 3. So, you are right. Like, this wouldn't be a fun thing to solve. So, if we go back to here, we could subtract now. What would we do first here? If we wanted to solve it like we did last week.
You do the square root of both sides.
Square root of both sides. Right now, is square root of 3 a rational value? No, so my answer is going to be irrational, but I can still solve it, right? This would end up being x equals negative 2 plus or minus radical 3.
I love it.
And even though it's not nice, I am able to solve it, right? Now, what if it was just x squared plus 4x equals 3? No, plus 4. Like,
You would. Wouldn't that mean it'd be a difference of squares?
not if we're missing the c.
Oh, yeah.
If we're missing the c, it's not
It's
different.
not a difference of squares. It's a weird square.
Solve these.
Okay.
I mean, we did b together, but solve that.
Do you mean with like the algebra terms?
It doesn't matter.
One is the product of our constants.
Really?
Are you sure? Wait, if it's a negative one, do you have to? Oh no, yeah.
But if it's not a square rectangle,
It means it's not.
that means we can't use what we've been learning, right?
You know what this reminds me of?
Anyone noticing anything interessante?
What does
It doesn't work.
What do you mean it doesn't work?
It doesn't work with your
Yeah, it does. What do we have when we can't do any other method?
Add the same thing to both sides.
Sure, but no. We'll be here all day.
Unless you get really lucky.
We could like add things.
You get rid of the.
I'll wait. I'll just, I'll check my Twitter or whatever. No, I don't even really Twitter.
Wait, you have Twitter?
Yeah, but I don't really use it.
Oh snap. Twitter is where
We really don't. You're telling me A doesn't solve.
Or do we put it in
No, it solves. But
I got negative.
We could do it in
one
like the
fifth. I did
negative b plus or
I need my
minus.
Bluetooth to connect.
Could we
x
do
What did
that?
you
squared
guys get?
plus
What did you get?
4x should equal negative 1, so just figure it
Wait.
out.
We could do like the negative b plus or minus, right?
Wait,
What?
David, what did you get for
What did I get? I got nothing yet.
I got x equals
Would you
negative
get
one
calculator?
fifth. You guys just agreed not correct.
Thank you.
Miyamo not correct.
Miyamo, what now?
Wait, I need to check my answer.
I definitely want my calculator.
I am. What just happened with your paper?
I moved it.
Come on.
What?
I think having a Twitter with it, right?
No, I'm not on Twitter. That was a joke.
Oh, that was. Oh, I thought you were being serious.
No, I'm trying to.
Okay, I think X has to be negative.
Well,
Yeah. But then, what's the number?
All right, well, it's fighting with me.
Are you being serious? I don't think that's how it works.
I don't know. I have a better idea.
Oh,
See?
okay.
Wait,
So she was right. It's a quadratic.
Big brain.
That's what I was trying to do. See if it
Big
would work.
brain.
If you try to solve a quadratic equation, I promise you it's possible without any frustration if you take everything, move it to one side,
Those are
so
doing
by
the
x
right
squared,
thing.
x and the rest. Alright, now take the coefficients, name them A, B, and C, and
That's a
if you
minus
use the right
square root of b
formula,
squared
you will
minus
see
b
that you
squared
get the
c.
solution and the very next
I
step,
think
just
you
set
said
the
one.
sum in your head.
Wait, over 2A,
Plus
right?
or minus the square root
Just
of
listen to
b
me.
squared minus 4ac over 2a negative b plus or minus the square root of b squared minus 4ac over 2a.
Oh, okay.
If you look at the screen on the floor,
Wait.
what happens if I take away 3 from my equation B? I'm left with an x squared, 4 x's, and a 1. Wait a minute.
Wait, I think I get it.
Wait a minute.
I think I got it. Wait, are we doing A?
This is A equal to 0. If I add 3, it's on both sides. It's equal to. Wait,
I think
you
I
should
did
be
something.
getting the same answers for A and B. A and B are the same.
It is. Because B is just. How do I say this?
I'm waiting to let that sink in. A and B are the same.
Yeah, because because it equals 0, but they're just subtract 3 from both sides.
Which is easier,
I feel like
A or B?
B, because you can do the square root, right? Oh wait,
B is way easier to solve. Taking the square root of both sides and then just subtracting 2.
you don't have
Oh,
to
yeah,
use a
well,
long
B-
formula.
And you don't need your calculator,
Wait,
really.
so could we basically. So what if we just turn A and like we factored it?
So here's the issue. When we set up A and we split the B value and we put the 1 right there, it's not a square. It's not even a complete rectangle. This can't even make a complete rectangle, right? Even if we just try to complete a rectangle, we're empty. So what we ask ourselves is algebraically, we can do whatever we want, right? What do I need to do to make this a square? Bring in 3. So here's the process we think through. Right, x squared plus 4x plus 1 on your paper equals 0. Now, this is the way I'm going to teach you guys how to do it, and then you can decide if you want to do it differently in the future.
Drop a 1.
Oh, if I did that, I would never find it.
I know, especially in this room. We're going to skip a section.
That again?
And we're going to write what we want. What we want is perfect square form.
Am I supposed to do the?
Yeah, like skip a, you can
No,
put a bracket
was I
there.
supposed to like do the equation to solve for A? Like that's
Mm.
what
I mean, if you have, rewrite it, and we're going to write it in a new way. Then, we're going to say, kind of like off to the side here, And this is going to come from, I know we're kind of working forwards but backwards at the same time. Sorry, terrible noise. And that comes from here. Now, this process will make more sense as you've done it a few times. But if we know that we're going to make a perfect square equation, what happens to make the b value if it's in a perfect square equation? Like, how did it get 4x?
At times, it was
It was
that
that.
in like
Where?
the foil, like the inner and the outer.
The inner and the outer. And since it was perfect square, the inner and the outer were the same, right? So
it'd be x times something.
Actually-
something times x. Right? Oh, yeah.
that's always b divided by 2
Yeah.
in a perfect square, right? Because the outer and the inner, the two terms that make it up. So this must be 2. Well, if that's 2, this would have to be 4,
And they
meaning
They subtracted 3 to get 1.
they added 3. So write this, then stick with me.
But didn't, so they had 4, but didn't they subtract 3 to get that equation?
They didn't have 4.
Oh.
We had 1 to start with.
I thought we were talking about how B went to A. I don't know.
Now, I'm going to leave this hanging as the wait, what? And we're going to come back to it after we try a couple more of these physically.
I actually think I kind of did it.
Good.
Which is kind of surprising. I'll probably soon find
All right,
out that I
grab-
wrote what I'm talking
Grab
about.
enough tiles to do this. X squared, and then write it down. X squared plus 6x plus 5. So we need 6 x's, a couple more x's.
I only have I.
This makes me feel a little bit smarter after Spanish.
You know what makes you feel? Oh yeah. Math class.
The test was pretty easy.
Now here's the interesting
I
thing.
can't Spanish.
I need another.
I can't.
I'm glad I'm not in Spanish.
X squared plus 6x plus 5.
It's a rectangle.
It can form a perfect rectangle,
But not a perfect square.
but not a perfect square. So if we tried to make a perfect square with it, if we try to make a perfect square with it, what amount is it missing?
4.
Yeah, we're asking what would go here to make it a perfect square. 4. So we add 4 on both sides. So in your notes, write a plus 4 on both sides.
Oh, well, we're supposed to write down the equation.
Yes, if you have not, please do that now.
It's not your decision.
What?
The one tiles. If it's on the red, you're fine. If it's not, you're screwed.
Oh, I should not do that in red. You remind me that red tiles are negative for us.
Yeah.
Oh. 1, 2, 3, 4.
I didn't mean to remind you. But sure.
I didn't mean to help you, but I did.
This becomes
Oh, I sort of get it now.
what was half of our B?
2. Wait.
3.
Oh, the B now. I was thinking. Never mind. I was thinking the 4. The 4 that we had.
I get it. Sort of. Oh my gosh, wow, I did not know tiles could be used to help me, actually.
Oh, this one's nice.
Because it
a normal number.
Because it's what's it called? The square thing.
Oh right, you always have to do plus or minus. I always forget.
-5, -1.
Right.
Now I'm surprised that none of you said this. Back when I made this. What are the dimensions of this?
It's oh, you already have your binomial.
We already have it binomial factored right here.
Yeah,
Right?
so
X
you
plus
don't even have to
1,
go through the trouble
X
of
plus
it.
5,
Wait.
X will equal -5, -1. But most of the time, that wouldn't work. It would not make a perfect rectangle. Because most of, like, imagine if it was x squared plus 6x plus 4. Now it's not factorable, quote unquote. Even if I try to move this up, oh crap, now I'm missing 4. Here I'm missing 1 if I just try to factor it as a rectangle. And here, if I try to factor it as a square, now we're missing a different amount. Now we're missing 5. Right? So to make it a nicer shape. Do the same sort of thing with B.
With B.
Yep,
Wait,
use your
what-
tiles if you want.
wait, what are
Remember,
those empty squares mean?
they're the negatives.
Oh.
Yeah. Now we can flip our tiles over. Oh boy.
Red color. New color.
Be empty with negative.
Let's start with our equation, and the job is gonna be solving this now for x. So let's take -c, multiply by 4a, and if you now add b squared, it always be too complicated.
I wonder if he has one for completing this
Just
square.
take a close look to the left side, and you see there's a binomial formula.
Because couldn't we use that one for B? The formula?
Hi.
Hi.
Hello. What is this?
It's him. It's the same dude.
No, but what is it?
I think it's not going to be in English.
I just listen to it anyways.
Well, what?
He's squaring binomials.
I don't know what he's talking about. But
He obviously put a lot of effort into the video on the mountain, and not as much into other videos.
yeah.
To complete a perfect square here, we would need this to be filled in. Problem is, right now, not only is that not filled in, but there are 5 boxes unfilled or lacking in space. So we would add 6 to actually make the left side have that 1.
Whoa.
Now, here's the biggest mistake people make. The trap door you need to avoid because there's dragons and snakes and monsters down there.
Or Mr. Hudson's disappointed look.
This number is pretty much always, now there are cases where it will be different, but you'll be able to quickly understand when it will. This number is almost always not the thing you did to both sides. And the trap door that students in the past, and me, myself, and I, used to love to make is when you're thinking through in your head, what do I need to do? That's not the number that ends up here. A lot of times it is the number that ends up over here. So we decided I need to add 6, right, to make this have a positive 1, which will make this a perfect square. That doesn't make that 6. The other trap door, because we needed to add 6 to make this true and make it a perfect square, this is 6, but the number we were looking to make was this positive 1, people will accidentally put that over here. They'll correctly put it there, but then accidentally put it here. These numbers are often different. Okay, so just watch out for that trap door. You're sitting here thinking, well, I wouldn't make that mistake because you haven't had the opportunity yet. Right? So let's avoid those trap doors together. Then this becomes just x plus 1 squared. This gets really fast once you're good at it. Negative 1 plus or minus the radical.
Yeah.
Questions?
I did it.
Did you drop it like it was
Wait,
hot?
hold on. You. Okay, it's the C.
Oh, yeah. I get what it is.
It's harder when we don't use tiles. Challenge yourself to not use tiles to think through these.
Oh, can we just draw tiles on it?
Yeah, but
But that's not what he's trying to do.
so mentally, I totally agree with think it through, but you can think it through like this, right? Your x squared values go here, but then we split the b into these two spaces. So I have a 2x and 2x, but they'd be stacked like this, right? Which means this space that would make it a perfect square, we want 4.
Yeah. So then you add 9?
Meaning we need to add 9. So we're not adding 4, even though we want 4.
We're adding 9.
We have to add 9. Technically, you could jump to this. Here's the danger. Danger!
Another
Danger zone. Here's the danger. We know that when we make it a perfect square, this is going to be half of your b value. Right? We're real comfortable with that. The dangerous part is getting this value. I want to push you.
Okay.
What's half of b? In b. Sorry. In b, what's half of b? Negative 3. Right. Half of b.
Oh, B.
You confused me.
So here, write this down real quick. Sorry, I'm moving too fast. Write that down.
You have C.
If you were trying to work quickly and you're like, oh, I don't need to think through it, I'm just going to cut the b in half.
That's a B.
No, but then negative 1 is
What's your constant?
Constant.
so it would be
Like, what is this?
That is
0. 1.
Wait. So
1 or 0?
It's 1, right?
I'm trying to get rid of the 1. The negative 1.
I'm trying to show you guys why you should not skip through these steps.
um,
And this is
Negative
the why.
would be negative 10.
Everything people are saying has question marks on it.
Would it be
And Sophia's question mark is starting to become more of a period.
Just like screen.
But erase that top of the question mark, right? We want a definitive answer. We don't want to be wondering.
Okay, so I think it's 10 because when you, when you did like the number that you'd have when you multiply them both together would be
Oh.
positive 9.
Wait, it's
Yeah.
right.
Yeah.
So you want a positive 9 up there, which means that you add 10. So the 0 would, where the 0 is, you add 10 to that. So now it's
Now it's 10, right? Period. End of sentence. That is the answer.
Wait, can she
So the trap door is when you don't take the time to say, what does this need to turn into? Well, this needs a positive 9, right, as the constant. But to get there, we need to add 10.
You need to add 10 to get 9.
Yes, because this starts at -1. The value we want to have at the end is a +9. So to get there, we add 10 on both sides. That's how the constant becomes the 10.
I think I'm getting this a lot much more.
If you tried to take the shortcut for C,
C.
what's half of your B?
-1. So it'd be way. That'd be
So
1.
that'd be 5.
This one does not start at 0, right?
Yeah.
So be very careful. What would I be doing on both sides? Well, I'd be shooting to make this, okay, x squared minus 2x. What would this become?
1.
A 1.
So you add 4, and then the 1 would become.
So I need to add 4.
Yeah.
This becomes
Oh, I get it. I actually.
5.
Wait, hold on.
And then this doesn't really matter. The trinomial that I thought through, I'm not going to use that. Right? We use our perfect square form now. So we haven't, on a lot of these, gone all the way to the answer because that last step is the easiest part. We just square root both sides and subtract our constant, or add our constant, depending on the situation.
I get it.
So
now.
here,
So
we're going to have
for-
+1.
For A, it would be really simple because we have 9.
So for A, yeah, back here, well, square root of 9, positive or -3. So -2 plus or minus 3. Oh yeah, we did solve this because we said -5 or then I just erased it. Sorry, for B,
Oh, yeah.
square root of 10, not very nice. So we end up, come on, smartboard.
We end up miswriting.
So radical 10 and +3. Any questions?
Wait, when we like graph these, wouldn't it be rough to get like the exact vertex because we need the.
I'm about to blow your mind.
Oh wait, no, they wouldn't because of the.
Don't blow your mind.
Just tell
I haven't
me.
processed everything.
Just tell you, that's no fun.
Yes, it is.
I haven't processed everything.
Say it.
It's fun for me because. my
Let's
mind
try
is
this. I'll
fun.
blow your mind while we work through this.
I'm guessing you want us to use algebra.
Use algebra to rewrite.
I need more X tiles.
I told her to get over it. I didn't put the title back.
Oop, that's too much. You put this in perfect square form.
What'd you say?
You can't put this in perfect square form.
Not how it is right now.
That's the fucking lesson. You gotta do something to it.
Why can't we put this in perfect square form?
Because 2 isn't a perfect square.
Yeah, 2 x's, x squareds, right? The 2x squared messes this whole thing up.
Multiply everything by 2.
Divide by 2.
Divide by 2. We want to
So
make
then I
it
didn't need to
easier,
get
not
all this
harder.
stuff out.
Are you kidding me?
No kidding in math.
Oh, come on.
Now this is still 11 because remember the left side is still the same thing.
So
I feel betrayed.
Now hold on. When we think through that whole like x plus 3 thing, because we took half of our b value,
we need like 7.5.
the constant needs to become 9. Right? This needs to become 9. So to do, wait, what?
Oh,
Are you
9
confused?
because 9
No,
because
I did it right.
The 3 squared. So then to do that, we add 7.5.
Yes.
and that'd be 18.5.
Yes. I get it. Sort of.
Now let's say I was debating when and how to blow your mind.
Oh,
I was wondering, was this supposed to be the...
No, but I don't want to do one that complicated.
no, blow my mind.
You've done it enough
So I
already.
can go to lunch speechless.
Sure, let's say x
You're
plus
never
3 squared equals
speechless.
17.
I was that one time.
If we want to graph this quadratic, quote unquote, we got to put it in quadratic form.
Yeah.
So we're going to move this 17 over to be with this fun binomial that is going to be squared.
Yeah.
Your vertex. Sammy, I'm blowing your mind.
I know.
You don't even care.
Okay, let's see this.
Do we still need our tiles or can we start putting them away?
Because I don't need this many. I can always get these out.
Perfect square form. Also puts it into graphing form.
So you just like flip the screen to get.
Oh, yeah!
The modification happening to your parabola, remember, is x minus h squared plus k equals 0, where your vertex is h,
I don't know if
Okay.
that's one.
Wait, what is H and what is K?
Oh,
horizontal,
Oh,
vertical.
why
I don't
is
know.
K?
I don't know why k is k.
Oh, no. I
Also,
dropped
some
one.
people in some circles would call it the constant.
Oh, it's
K
actually
constant.
called K.
I dropped
Yeah,
one.
it is actually k.
It did not land.
I see it.
We'll do
Oh,
more of
see,
this,
sure.
right? So I won't like do stuff.
Or I don't know why you guys. Well, we don't need your tiles still.
I need practice.
Let's do another.
Wait, we do still need our tiles?
No, let's do another.
I
Another. I need more
Another
practice.
one.
So
Oh, now we have
Jessica, what's she doing?
decides to use horse.
So
She cut one act.
here's the other way you can do this. Even if you're picking up, I need your attention. The other way we can do this, and this is how CPM kind of suggests that we teach it, but you guys are not normal.
Nope.
Trust me, we're not normal.
I know.
If we want to quote unquote make our life easier, we should get rid of the constant that is with our like trinomial first. So how CPM says it is when you start with x squared plus 5x plus 2, get rid of that 2 because it's not what you want. So add 2 to both sides. Then they say it's easier to work this and say x plus 2.5 squared is going to leave some like constant that we don't have right here. Right, well, 2.5 squared is 5.25.
Let's
Wanna
see.
say?
2.5 squared. 6.25.
6. I knew I was off by something. Sorry, I'm trying to fit this all into the remaining time that we have.
I don't know how well it's working.
I don't know if I'm touching
You need your other half of this.
I didn't need this one to begin with. Here's why CPM says it's easier. The thing you add on both sides is this value squared. So instead of us having to think about what is it that we add, they say, oh, just square your half b value and add that to both sides. That works if we moved this first.
Okay.
So if we've done that, this is always b divided by 2 squared.
Wait, I think I don't really.
So let me run through another for you real quick, and then we'll get you out of here.
Yes, you're going really.
Well, we'll get you out of here.
No. Never mind.
I'm confused on what's happening.
Yeah,
I'm a
that's
little
what I meant.
confused.
Yeah.
This is what we start with.
Yeah.
How CPM and a lot of teachers teach it is this isn't what we want, so push it over here. We really have x squared minus 6x something that we'll add on both sides.
Okay.
Okay.
So
Then
maybe
we can-
x minus
Go ahead.
3.
Yeah.
X minus 3. Well. And then square. And
So then it'd be
just
9.
that
that
9.
you add to
You
both
add
sides.
9 both sides, so 2.
That's why CPM thinks it's easier, is then you just square that value and that's what you're adding.
See?
You don't have any other thinking to do.
That seems
The only
easier.
difference is then that thinking kind of happens over here. So, same thing with this one. Just to show you that method. Maybe we should have gone that way first. Maybe I'm sorry. I realized that. My head was ahead of myself. So this, get rid of the 3, becomes an equals 3 over here, right? X, what would go in here? Plus 5, right? Half your b squared would actually make the constant 25. So we would have
Then
added.
it'd be 22 on the other side.
That's where this is
Oh
dangerous.
no, because you'd add 3 to both sides instead of having the negative.
So
on
you
the
still
other side.
need to very carefully think about what is happening in that step to get this to be true.
CPM wants us to not think when you have to think.
Really, it's whatever method you think is best.
Okay.
I like the CPM.
Thank you very
Could
much.
I leave
Really,
my
that
calculator in
is-
charge?
That's how we teach completing the square. But when we do it with the algebra tiles first,
Oh my goodness.
hey, just to kind of defend myself, when we do it with the algebra tiles first, this doesn't make sense, right? To move these, or like the first way we did it with the actual tiles made sense to just bring in more tiles, right? Not to get rid of tiles, to then bring in more.
I really, really hope I can remember.
So the difference is if we took something like this, so I want to make sure it makes sense. What I just showed you right at the end would be get rid of these tiles and then bring in 9,
Yeah.
right? That doesn't really physically make sense when we could just bring in 5, right? That's the difference between the two methods.
Okay.
Same answer though, same mathematically. Have a great day, guys.
Mr. Hudson.
Yeah.